Press F5.
Well, I want to sort of go in the opposite direction to what most of you have been going. And instead of investigating things at just, say, the microscopic level, try and find out why it is that we're all here trying to do science. Being a process from the very beginnings of the universe, which has resulted in our being in this room and all being interested to take to do scientific research and to see if we can. So we're really talking about taking the equation that Peter Rowlands exposed you to this morning, and seeing if we can, if there are some logical steps, by which we can explain the evolution of intelligence. Do we know how?
Arrow to the right.
Arrow to the right.
Yeah, that's it.
So the interest of the British Computer Society Cybernetic Machine Specialist Group, whose remit is the physical foundations of computation, started formally in 1986 when David Deutsch gave a repeat of his talk on the Church-Turing principle and the universal quantum computer, which was published in the Royal Society of Proceedings. And the leading question that seemed to come out of the debate at the end of that talk was the question about the brain's architecture. That is to say, why is it so different from that of a digital computer? And could physical law explain this, in particular quantum mechanics? So, but the leading question I want to try and address today is, does Rowlands and Diaz' 2002 discovery of the nilpotent universal computational rewrite system, which resulted in the Dirac equation that Peter talked about this morning, and what it predicates, describe a self-organized computational unification of scientific law by spelling out a universal semantic language, not just for experimentally validated quantum physics, but for the whole of physical reality. Because this rewrite system is not just concerned with syntax and logic. It's concerned with semantics, what things mean, and the things that emerge from the language describe physical realities as we've all come to know it and has happened from the experiments that have been carried out over the last 200 years or so. So all the work since about 2002 has resulted in our being able to say the following: that there's an Einstein's law of conservation of energy, mass and momentum, that starts this emergent process off, and subsequently, with respect to relativistic space-time, both Lorentz and Einstein gauge invariant, there emerges the standard model of elementary particle physics as we know it. And the next step in that emerges is the periodic table of the atomic elements and chemical variables. And then the molecular biological basis of the RNA, DNA genetic code. And this enables the postulate via the language of the human genome that natural semantic language thinking at the higher rewrite level of self-organized emergent molecular chemical complexity of the human brain is potentially realizable by the same computational language, computational language, universal language bridge. So this is a diagram which best to it more or less says that there are, in this process of getting to where we are now, we've got these 7 stages essentially, which I shall try and explain in the further on as I progress with the lecture. So the write-rewrite system predicts a primeval dark energy from which 1 and 7 are emergent, and 1 determines the laws of thermodynamics, and in particular this Einstein conservation equation, and the second law as it applies in a single heat bath. So we need that because this is going to be a self-organized system. This is going to be a self-organized mechanical unit. And then the next stage in working through this language, we get the nilpotent-Dirac equation, which Peter did some explanations about this morning, and that leads in his book on zero to infinity to the standard model of elementary particle quantum physics. And then if we step forward to a further level of complexity, and this can be actually set out in, for example, Varl's book on group theory and quantum mechanics. You can find there, in agreement with the basis on which we're working, the laws of atomic chemistry, variance, and the periodic table. And then I shall show the symmetries of RNA and DNA genetic code are, as Vanessa, Hill, and Peter have shown are the same as although the molecular structures are more complex than the standard model of elementary particle physics. They exhibit the same basic symmetries and symmetry break. And so, as we know that the DNA, RNA genetic code enables us to encode the human genome, which includes the brain, mind, and the senses. Then we could say that we would expect to find these symmetries here and there, repeated here, and that is indeed the case. And also, we should be able to explain that these semantic laws of natural language, which we can show conform to Wittgenstein's semantic principle, take this form with which we originally started out talking. And so these provide us with an intelligent semantic means of understanding the science of the cosmos, and this is a sort of embryonic icon for the start of science than the apple falling on Newton's head. And this is just this is hope. This is Pandora opening her box. So here's, as I said, this is worked out by P Rowlands and about the relationship of symmetry between the two, between biology and physics. So, in a sense, in a computational sense, we can say that they have the same order code, although that order code has been rewritten in the case of biology at a higher molecular level of complexity. So, I'm going to ask the question, is the book of the universe actually written in this language of universal rewrite computation? Because already a great deal of research has actually been done since 2002 to enable us to postulate that the self-emergent rewrite construction describes the basis of much of physical reality as currently known to us through experimental science in physics, chemistry, molecular biology, and neurophysiology. Now this is the, I don't think Peter's got his book with him, but
No, they're on.
This
You guys will bring it in tomorrow.
a lot of this appears in his book. There are quite a lot of contributors to this book, but indeed the main work, and it's a very extensive and detailed work, is carried out by Peter. So this is what we call Einstein's conservation equation of energy, momentum, and mass. And I've described the way the construction that Peter uses in his book as I've described as a mapping of 0 to 0, but it's going from an origin back to an origin in a logistic symbolic language, which predicts this particular generic Dirac Fermion operator, now one of the features of this operator is that it has an infinity of non-trivial self-similar solutions or roots not equal of fractal dimension 2, each corresponding to a letter in the NUCR alphabet, which spell out the semantics of its universal grammar. So all the symbols in the alphabet correspond to these fermionic states that as pointed out. Is always 0, even though each of the fermions themselves are non-zero. And the way the construction works is that each time you return to effectively to 0 of the origin of your the argument of that stage by advancing the construction, then the new x must differ from, but be compatible with, all the x's that precede it. But you always get this 0 to come. Now, there's a second law of thermodynamics that fits very well with this process, and it concerns the quantum coherent phase theta, and this paper appears in Science. Now, this fundamentally alters ideal Carnot heat engine efficiency from Vigier, which depends on there being a synchronous source of temperature, which are different to having this extra term here, which means that you can actually have entropy changing due to phase, even though you're in a single heat path. So, and we need this if we're going to have a self-organized universe. But the other. So in this rewrite, nilpotent logistics, this computational, this includes universal. It describes quantum computation. This is a computational description of the universe, and that's in agreement with what the work that Deutsch published in 1985 that I mentioned earlier. The principle of fermion Pauli exclusion explains the distinction between a quantum and a classical automata. Quantum automata knows things about itself that it can't communicate to anybody else because it has this unique property that only it has. So it can't tell you about it because you don't have any experience of that property. So all of us, this is one of the difficulties I think that we all have, but we're all uniquely different. And we know something that ultimately we cannot communicate to each other. So I'll explain later on how we do manage to communicate to each other. Now this particular process has an infinite alphabet, and so it actually never holds. So this is one of the differences with digital computation. The process has solutions, but it doesn't hold. And its logistics could be implemented thermodynamically as a phase mapping onto a phase. As Feynman pointed out in 1986, the universal digital primitive NAND needs further single primitives of exchange, fan-in, fan-out, and the unit wire to describe the quantum construction of a digital computer. So there are things that this set of primitives can do that cannot be done on a digital computer indeed. And one of them is actually constructing the computer itself. This really provides an explanation which predicates the store program digital computer from having a secret folder from Neumann signal architecture, and his discovery of another property of computation, which is universal computer construction. So this universe, in many ways, operates by constructing more complex structures rather than by advancing itself logically, although that happens as a secondary process. Remarkably, in this cosmology, Heisenberg uncertainty is a dual relationship, and it's not an obstacle to computation. It's actually the means by which exponential complexity can be optimally controlled, and that's one of the difficulties with digital computation. If a process gets exponentially complex or exponentially complex, then you can perhaps write a program for it, but the program will still be running at the end of the universe, if there is an end to the universe. And in this particular model, quantum phase coherence can be identified with entropy in this quantum Karnaugh engine. And it's not simply a measure of disorder, but it also has a dual, and that dual is the metric of physical complexity, which leads thermodynamically to the creation of entirely novel ensemble states of matter which may never have existed before. Properties that didn't exist in the past, or at least weren't observable in the past. Which means, of course, that if each of the neurons in our brain is self-organized and considered as a quantum mechanical ensemble, then that ensemble could have an entirely new kind of properties which never existed before, and that might be, one can postulate that might be consciousness. But this particular process would be responsible for all the new kinds of states of matter and material properties that we observe in the world today that weren't observable at the beginning of the universe. Now, this is a diagram which of Walter's that he sent me many years ago, so I have to thank him for this. And this more or less shows the quantum signal decay losing amplitude on this axis here, but simultaneously regaining it longitudinally effectively as phase, so that the brain slice selected for measurement by the prepared electromagnetic pulse train applied in MRI is transformed thermodynamically into a wave diffraction pattern, or quantum hologram of the brain slice. I think in the latest descriptions that Walter gives, the process is much more much more complicated. I think this describes what happens in perhaps the simplest of the non-quantum machines in very elementary terms. Now, this is again, we've shown this yesterday. This is a picture by symplectic Fourier transform action, and here you just take the little bit inside the paper when it comes out. But now we need to ask some questions about this conservation equation that Peter I would say that if this conservation law is to hold everywhere, that is at each point of a 3+1 space-time, then there must be a set of coordinate axes of 4 mutually independent directions erected so that there's a metric of P. And computational processes always have to have measures and metrics to describe the wave, the field, the quantum wave field quantity in terms of its components, so that these are obtainable from each other by means of local Lorentz transformations which lead to P and And if you're going to have the I haven't got new there because I altered the P. I altered the thing at the beginning, so it's come out like that for some reason. Then, if this equation is going to hold again over all space-time, then it must be gauge invariant under arbitrary infinitesimal transformations of the coordinates RT, as established in as is already the case in the established series of general relativity and electromagnetism. And this is only possible if the 4 components of the wave function are determined up to a common arbitrary phase factor, as is actually the case in the in the quantum formalism. So this is a very important condition in being able to have this So we now need an answer to the leading question of can there actually be an infinity of possible solution dates to this Einstein conservation law, delivered in terms of, for example, a single phase growth. One answer to this question is yes, but we have to use the multi-valued Riemann surface, whereby each branch of the phase is converted into an analytic function on a more general surface, which in this case will be that of the conservation law, by associating each branch with a separate plane or sheet interconnected in a consistent fashion. Well, this would actually be the genetic code, the genetic coding. You can think of the genetic code as being the geometric helical structures of phase mapping onto itself. And it would have two kinds of nilpotents. You would have the R and A nilpotents, where you introduce a new fermion state into the system, or whatever you are doing, so that it's not, so that it is a new fermion state. And in the DNA nilpotents, you always have the phase conjugate. Two-phase conjugate helical states, helices together, and they basically add up to this zero. So they are, and the sheets and planes are those of the base pairs A and U and A and T, which together with G and C make up the entire cycle of life with respect to this process of universal computer construction. Now, if we look at the quantum phase architecture that comes out of this, then the Riemann surface identifies each newly emergent sheet, theta J, with a hologram plane J, such that the wavelet mixing specified here is described by a hologram transform here in terms of this three-dimensional Heisenberg Lie group, quotiented by its one-dimensional center. This specifies a holographic lattice of 2D pixels xy in the xy rate on the hologram plane. And if this is the case, then this allows the object image bearing beam psi to be mapped with on the hologram, to be recorded in the hologram plane J by mixing it with a reference beam, such that the quantum coherent wavelet mixing specifies the probability of detecting, say, a photon in a unit area attached to a point of that plane where the trace transform describes the self-interference of the photons. And this condition, which is the condition for gauge invariance in this system, is satisfied. Now, as I say, an example here, which I can briefly refer to, is the this trace transform, which is the self-interference probability of detecting a quantum within a unit area xy of the 2D pixel array inside the hologram plane. We can postulate that it's as observed by echoes in the synapse of the mammalian neuron. That is, it takes this takes the form of the probabilistic release of a single vesicle from the predicted hexagonal vesicular grid, that's the pixel array, to give the flux of 10 to the 4th neurotransmitter molecules across the human synapse on neural fibers. So each neuron is effectively self-organized and linearly independent, but they would form a further ensemble and so thus these holographic phase transforms, frequency V, describe a phase conjugate adaptively coupled associative phase frequency memory and filter bank of 4 quantum wavelet mixing, these cores, which produces the holographic spectral pages, which is described like this. As Walter has shown, this frequency phase associative memory is optimally organized and can perform rewrite, memory, and filter bank operations. And it consists of very narrow spectral windows or pages, each able to carry holograms on its spectral blade. And these pages and windows, because of their narrow spectral character, are essentially isolated from one another. But this is only possible because the uncertainty, the Heisenberg uncertainty relations have this duality which I've described, which concerns G, which is the Heisenberg group, and little g, it's the algebra. And these two are effectively diffeomorphic. And so one is the inverse of the other. And if one wasn't the inverse of the other, then you wouldn't actually be able to do holography. Now this architecture could be said to provide a solution to the hard problem of how objective third-party communication is achieved despite how unique to the subjective character. What, 5 minutes? For our holographic sensors allow each of us to see, hear, etc. Objects exactly where they are located in 3-dimensional space by the use of phase conjugate 3D imagery. So I see all of you outside my head, and the images that my brain forms coincides with where exactly you all are. And in terms of perception, this happens practically instantaneously. This can be done at the back of the eye. If I then want to cognize the thing, I have to send this holographic signal back into the brain where the holograms are organized together to form a filter bank. And that would then allow me to identify each of you according to previous perceptual input and recognize you by all the information that was stored in the filter. So this actually allows, because images are phase conjugate, this allows each of us to exchange our subjective experience of objects simply by pointing to the object in question or an image of it, or even by just saying its name in this semantic language, which we may share with a third party. And in this case, the semantic language is English. Because no two objects on our particular scale can share the same position at the same time. So we can overcome this problem to a large extent. I can't tell you the thing that I know about myself that maybe only I know. But I can tell you about the third world, the world around me, and we can communicate about the third world around us simply by saying, well, look, that's this is the whiteboard, and we all see that whiteboard exactly where it is, where it is. And if you think about it, it would be absurd for our sensors not to use all the information that's incident on them in terms of both amplitude and phase. For as holography shows, this allows us to perform an immediate, real-time, three-dimensional holographic construction, stroke perception of the incident information on our sensor apparatus.
Peter, do you think we've come to a conclusion?
Yes, I was just going to show one more slide. Well, one of the facts that I think supports this argument of self-organisation is the fact that if there's a wave incident on an object, then the three-dimensional geometric object image is encoded spontaneously in the wave by means of these local changes. And this happens totally independent of any observer. It's just a fact of the universe in which we live. And you can demonstrate this by the holographic capture of this image, and then subsequently removing